Hey everybody, welcome to Easy Algo. In this video, we will be covering a question called finding the merge point in a linked list. In this question, we will be given two linked lists and we have to find that at any point these two linked lists merge or not. And if merge, then we have to return the data of that particular node. For example, here we have our first linked list, which is 1, 2, 3, 4, 5 and 6. And we have our second linked list 7, 8, 5 and 6. So as we can see, these two linked lists intersect at this point where the node value is 5. So we have to return the data of this node, that is 5 in this case. So let's see how we are going to do it. So our first approach will be, we can use a hash table for this one. What we will do, we will start traversing the one of the linked list. Let's say here we have our hash table. Now as we traverse our linked list, we will store all the values in a hash table. So here now pointer is at 1. We will store 1, then 2, 3, 4, 5 and 6. So we have stored all these values in a hash table. Now what we will do, we will traverse this second list. Now as we traverse the second list, we will also check that is the pointer value is matching with any of the element in the hash table or not. For example, if we traverse in this list, we have the pointer at 7. So pointer is at 7. Is 7 in our hash table? No, it's not. So pointer will be shifted. Now pointer is at 8 here. Is 8 in our hash table? No, it's not. Now pointer is shifted. Pointer is here. Now is 5 in our hash table? Yes, 5 is in our hash table here. So we got our pointer position at 5, and as we got our intersecting value, we will simply print this value. So this is one of the approach to solve this problem, to find the intersecting point. And although this takes linear time complexity, and also we are using extra space for creating a hash table. So let's see if we can minimize our solution or not. Now let's try to optimize the solution. Let's try not to use extra memory. Okay, now what can be done, we can use one more method, that is we will calculate the length of these two linked lists. Let's say L1 is the length of this longer linked list. We have 1, 2, 3, 4, 5 and 6 elements. So we got 6 element here, and we got, let's say, L1. So 1, 2, 3 and 4. So L2 is 4. So what we will do, we will calculate the difference between these two lists, or we can say the absolute difference between these two lists. We got the difference, which is L1 minus L2, that is equal to 2. So the difference is 2. Now since we got our difference, now what we will do, we will start traversing the longer linked list. So this is our longer linked list, this L1. So pointer is here. We will start traversing this list up to the point 2 or up to the point difference. So this is 1 and this is 2 here. So we have to traverse till the difference. That is, for example, if we got the difference 4, then we have traversed till this point, this 4 here. But since we got our difference 2, so we will only stop at this point. Okay, so let me erase this pointer. Okay, now we have traversed till the difference here. So the pointer is here. Now what we will do, we will simply ignore these parts. This is the pointer part, and we will simply ignore this part of the list, and we have only our list from here only, that is from 3. So our next traversal will start from here only. Now as you can see, after removing this part of the linked list, we have actually got these two linked lists of same size. That is, if we calculate the length from now, we got 1, 2, 3, 4. 4 is the length of L1, and we got 1 2 3 4 is the length of L2. So after removing this part of the linked list, we virtually got the same number of nodes in both the linked list. Now we can traverse this list using a single loop. So we will start our traversal. So we will set our 2 pointers here and here. Now both the pointers set. Now we will start traversing simultaneously. Now at any point, if these 2 pointers get the same value, then we will simply return the value of that particular node. So pointer will be shifted. Now since these 2 pointer is of same value, no, it's not. We got 3 here and 7 here. So pointer will be shifted to the right. So pointer is now here and here. Is 4 and 8 same? No, it's not. So pointer will be shifted here. We got pointer at here and here. Is these 2 pointer points to the same node? Yes. Now this points to the same node, that is 5 here. Now as we got our common node, we will simply return the value of that particular node, and 5 is our answer. So this is what the second solution is, and in this solution we actually don't use any extra space, so we can say it is more optimal than our previous solution. Now let's see the code implementation for this solution. Okay, so here we have our code. We have get intersection node function which takes D as an input, node 1 and node 2. D is basically the difference between the length of both the linked list. Then node 1 and node 2 is the reference of the head of both the linked list. Now here we have initialized the I variable. Now here we have create the reference of node 1 and node 2, which will help us in traversing. Now to make the length of both the linked list virtually same, we have to have some initial traversals. So this for loop is basically for traversing or shifting the pointer to the D ahead in the longer linked list that we have actually discussed in the algorithm. So for I0, I less than D, I plus plus. Now if current 1 is null, then simply return -1, that is we don't got any linked list. Else current is current dot next, that is keep traversing. So this for loop is basically for shifting the point or shifting the pointer at that point from where the length of both the linked lists are virtually same. Now here in this while loop we will start traversing both the linked list simultaneously. Now at any point, if the pointer values of both the linked list is same, that is current 1 dot data is equal to current 2 dot data. In that case, simply return the value of that data, and we have got our answer. Else keep traversing, that is current 1 is current 1 dot next and current 2 is current 2 dot next. So this is the get intersection node function. Now here we have our supporting function, which is get count, which will help us to find the length of the linked list. So nothing special here. And this is our actual function get node, which will get us the node. That is here L1 and L2. L1 is the get count head, that is it will count the length of the first linked list, then L2 which will count the length of the second linked list. Now here we have initialized the variable D, which will store the difference. Now if L1 is greater than L2, that means L1 is longer than L2, then the difference will be L1 minus L2, and in that case return get intersection node D head 1 and head 2. You have to take care of these three arrangements. So now else D is L2 minus L1, else in other case L2 is greater than L1 or the length of the L2 is more than the length of L1. So in that case return get intersection node D head 2 and head 1. So as you can see here, we got reversed, our input is reversed, that is head 1 and head 2 here, and in this case we got head 2 and head 1. So you have to take care of that. So that's it for this video. If you enjoyed the video, hit the like button and subscribe to the channel for more coding interview problems. See you in the next video.